Hi students, on this video we're going to conclude our solving quadratic series, this time looking at solving quadratics by using the quadratic formula. Alright, so after watching the video you should be able to recall the formula and application of what we call the discriminant to determine the number of solutions that a quadratic will have. After that we're going to use the quadratic formula, which uses the discriminant to help us solve some quadratics. Alright, the biggest things you'll have to recall before you watch this video is remembering that solving just means determining a value for an unknown. That is, what number does x equal to make an equation true. You need to remember the standard form of our quadratic equation. That is ax squared plus bx plus c. We're going to use those numbers or those values and those parameters quite regularly. So you'll have to remember that too. Okay, so when solving quadratics using the quadratic formula, it's often useful to talk about the discriminant first. So the discriminant is a useful value that tells us the number of solutions that a quadratic equation is going to have. The symbol we use for the discriminant is this one here. We call it a delta. And it's calculated using values from a quadratic equation, ax squared plus bx plus c. So a is the coefficient of the x squared term, b is the coefficient of the x term, c is our constant. When that equation equals 0, the discriminant equals b squared minus 4ac. Now, a couple of rules around this. So if delta is positive, if delta is greater than 0, then the quadratic has two real solutions. Okay, two real solutions. Now, if delta equals 0, then the equation has only one solution. And then finally, if delta is less than 0, that is, if delta is negative, then the quadratic has no solutions, or no real solutions to be more accurate. So if delta is positive, two solutions. If the discriminant is 0, one solution. If the discriminant delta is negative, no solutions. All right, so in a couple of examples, let's determine the number of solutions for each quadratic equation. The key thing with our quadratic equation, guys, is we need to make sure that if we want to use the discriminant, our equation, one side of our equation has to equal 0. So in this case, I'm going to subtract 2 from both sides. So it's x squared minus 3x plus 2 equals 0. And then our discriminant is going to equal b squared minus 4ac. b in this case is negative 3 squared minus 4 times a, which is 1. Right? Don't forget the invisible 1 in front of our x squared term there. So invisible 1, then times positive 2 is our c value. Now evaluating that, negative 3 squared is 9, minus 4 times 1 times 2 is 8. That equals 1. That number's positive. That's greater than 0. So therefore, this particular equation will have two solutions. For the second one, again, we need to do some rearranging. So subtract 5x from both sides and plus 8 to both sides. So we'll have 2x squared minus 6x plus 8 equaling 0. And then we've got our equation equaling 0. We can now use our discriminant. It's going to be b squared minus 4ac. b is negative 6, so negative 6 squared. Guys, make sure when you substitute in your negative, make sure it's in brackets so you remember to square the whole thing and make it positive, basically. Minus 4 times 2 times 8. 4, a value is 2, c value is 8. 36 minus 4 times 2 is 8. 8 times 8 is 64. That number is going to be negative, just looking at it. 36 takes 64. I don't know what number it is, but I know it's going to be negative. So therefore, because our discriminant is negative, there are no real solutions. for this particular equation. It's not solvable using real numbers. All right, now for the quadratic formula, if we've got our quadratic written in standard form, where it equals 0, okay, the values for x, the solutions, can be calculated using this formula, where we've got negative b plus or minus b squared minus 4ac. Notice here, guys, that is our discriminant, right? That is our value of delta. So we can say our x values, our solutions are actually negative b plus or minus square root discriminant over 2a. Okay, if you wanted to, it's often helpful to find the discriminant first. The discriminant lets you know straight away, oh, how many solutions do I have? If I have 0, there's no point continuing. Is a good way to use the discriminant. If it's negative, you can stop and say there are no solutions without doing any more work. But if you do realize there are solutions, you can then use the discriminant straight away in your quadratic formula. And we'll show you that in an example now. All right, we want to solve the following equation using the quadratic formula. So once again, when we're solving quadratics, it's good to make one side equal to 0. So we'll subtract 5x from both sides, and plus 9 to both sides. And so our equation will be 2x squared minus 6x plus 3 equaling 0. Now a good start is to determine our discriminant. It's b squared minus 4ac, negative 6 squared minus 4 times 2 times 3. So that's 36 minus 4 times 2 is 8. 8 times 3 is 24. 36 take 24 is 12. Okay, so therefore our discriminant is positive. So we've got 2 solutions. We'll have 2 answers. So we may as well keep going. We should keep going because we know there's definitely going to be 2 solutions. Right, so our quadratic formula is x equals negative b plus or minus the discriminant, or square root of the discriminant, over 2a. And just subbing those values in, we'll end up with negative b. So negative of negative 6 is just positive 6, plus or minus square root of 12 was our discriminant, divided by our a value is 2, and then 2 times 2 is 4. And there's our solution. So remember here, students, we've got 2 solutions here. We've got 6 plus square root 12 over 4 and 6 minus square root 12 over 4. Those are our 2 solutions that we knew we needed for this problem, all done using the quadratic formula. Right, so after watching this video, students, you should be able to recall the formula and application of the discriminant to determine the number of solutions the quadratic has, and then use the quadratic formula to solve some quadratics.